All right, today we are graphing sine and cosine again, but this time we're doing phase shifts. So what that means is that we are going to move it left or right. Now, if you look, our B is on the outside here. So if we do not have the B parentheses, we're going to have to factor that out for the B. Also, remember with transformations, when we do it to the X on the inside, it's pretty much the opposite to what you see. Okay, so when we have a minus H, we're going to move that to the right, and when we have a plus H, we're going to move that to the left. So, number one, the first example. The first thing I want to point out is that it is sine, and it's a positive sign. So we are starting at the midline, and our next coordinate is going to go up to the top. Midline because it's sine, up because it's positive. All right, and then the other thing I'm going to do is rewrite this so our B is there. Now, if we look, we want X to have the coefficient of 1, and it does. So technically, we're just factoring out a 1. That will make more sense in the next problem. Okay, so let's fill out our amplitude and everything. Amplitude, remember, comes from the front, the coefficient in front of the trig function. So our amplitude is 1. Our period, it is 2 pi all over the absolute value of B. Well, B in this case is 1. We are going to break that down into 4 sections. So remember that we divide that by 4. So that comes out to pi over 2 pi 3 pi over 2 and so on, 2 pi. Phase shift. The first thing I think you guys should write down is whether it's going left or right. This is a subtraction. So we are going to the right pi over 2. Now the vertical shift here, I know this is different, but I'm going to rewrite this. This is also the midline. Last video I made a mistake because when I put it in function form or line form, because it's a horizontal line, I wrote down the wrong variable. So the midline in this case is going to be y equals, and we're going up 3. Now, when we graph this, I really want you to focus on that phase shift because we're going right. So that tells us we're going more this way. That allows me to know maybe I should put my y-axis on the far left. If we are moving to the left, I would want to move this y-axis more right. Okay, and we are going up 3. And then our amplitude is 1. So I just want to make sure I have enough room. Just like last section, I'm going to label the midline and the amplitude. So midline 1, 2, 3. Okay, let me darken that so you can see it. And then our amplitude is up 1. And then down 1 from that midline. Maybe I shouldn't use pink anymore, guys. Okay, I'll just finish this up. Now, I'm going to label our coordinates on the x-axis first, Now, if this were covered, I might move them down here so I can see what's going on, okay? But considering I can label on the x-axis, it works. So we're going by pi over 2. So I'm going to label pi over 2 plus another pi over 2 is pi, plus another pi over 2 is 3 pi over 2. There is our 2 pi. Now, last chapter we stopped right there because that was a full period. But if you look, guys, we're shifting over another pi over 2. So I'm going to go one more over, which would be 5 pi over 2. If this seems a little confusing, stop the video right now and call me over. Now let's graph our function. Again, we're starting at the midline, okay? So we're starting at the midline, but we have to shift it over. There are two things we can do, and I'm tempted to do that now. I'm going to draw the original without the phase shift, okay? Which means we would go midline, up, midline, down, midline. So that's what we graphed last week. But considering we are now doing a phase shift, we are going to move each point by pi over 2 to the right. Pi over 2 is 2 spaces. So my midline starting point comes here, then goes up, midline, low, midline. So now that phase shift, it is up to you whether you're going to draw that first set of points and then the phase shift. I'll leave that up to you. I won't take credit off if you do not do that. All right, example 2. I want to point out that it's cosine and it's positive. Cosine means we start upper or lower. Upper is the positive, lower is the negative, so we are starting at the high one. Okay, this is in the form where it's already factored out, so this is perfect. We don't have to rearrange it at all. Amplitude is what's out front, so we have 2. The period is 2 pi over b, which in this case is 2, leaving our whole period of pi. So if we were to break that down and divide that by 4, we are going by pi over 4, which gives us pi over 2, 3 pi over 4, and pi. Our phase shift, again, is subtraction here, so it's to the right. We are going right pi over 4. And our vertical shift, which again is our midline, is going to be y equals 1. We are going to the right again, so I'm going to have my y-axis close to the left side. Let's see, we are going up 1 and then amplitude of 2, so being right in the middle is okay. All right, let's see if I can get a different color instead of that pink. All right, so our midline is at y equals 1. Our amplitude is 2 up from the midline and 2 down from the midline. So remember, that means I'm only putting my coordinates on these blue lines, the up, the middle, or the lower. Okay, so last time what I did is I labeled my sections, my intervals here, But I'm not going to do it on the x-axis because, as you can see, it gets a little crowded. So I'm going to do it down below. Remember, we're going every 2 spots to space out the graph. And we're going by pi over 4. So pi over 4, pi over 2, 3 pi over 4, pi. And because we're shifting to the right, I'm going to go one more, so 5 pi over 4. Okay. I'm still going to draw the original graph before the phase shift so you can see those coordinates. Cosine, we're starting up on the y-axis. Every time I go to a next section, I'm going to go on my midline, upper and lower. So up goes to midline, goes to lower, comes back up to midline, and ending up. That is what we did last time. So this time we are moving to the right pi over 4. Pi over 4 is just the 2 over. So I'm going to move each of these points over by that 2. And then put them together. And there is our cosine. All right. Last graphing example. So this is a negative cosine. Well, cosine is either up or down, and then the negative tells us which one it is. So it's going to be starting at the lower end. Also, we have we need to factor out 1/3. Factoring is like dividing out, so it's negative cosine. We're factoring out a 1/3, leaving x plus. Now, imagine this as pi, and I said we're dividing that factor out. So we have pi over 1/3. Well, dividing by a fraction is the same thing as multiplying by the reciprocal. So what's the reciprocal of 1/3? 3. So we're going to multiply by 3. So that gives us 3 pi minus 2. All right, our amplitude is the coefficient up front, which is 1. You could put -1, it's okay, but negative is already considered that we're flipping it. The period, 2 pi all over 1/3. Again, dividing by that fraction is multiplying by the reciprocal, so we get 6 pi. Now, when we break this up, remember that we're looking at our period divided by 4, okay? So that gives us going by 3 pi over 2. So if I kept adding 3 pi over 2 to itself, 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. Okay, remember the denominator stayed the same. So 6 pi over 2 reduced is 3 pi. I'm going to keep thinking of this as 6 pi over 2. 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, which is 6 pi. That's our period. Okay. Now, we could keep going, but if we look at our phase shift, which direction are we going? We are actually going left by 3 pi. Okay, and I want you to notice that 3 pi is twice the amount of movements that we were making before. Vertical shift is y equals -2. All right, so we were saying before that we were putting the y-axis right here. But as you can see, we're going to the left. I said before, we are going to the left 2 sections. If you remember, we were making each section up here 2 spaces. So if we kept with that tradition, we might want to think of it as we need 4 sections to the left. And I want a little space. So 1, 2, 3, 4, and then let's do our y-axis right there. We are going down 2 for our midline, not 1, so let's put the x-axis a little bit higher. The midline is at -2. And then our amplitude, so we have 1 up and 1 below that midline. Okay, I'm going to stick with putting the intervals or sections down here. So we're going by 3 pi over 2. This gives us 3 pi, 9 pi over 2, and 6 pi. Now we're going to the left, guys, so I'm going to continue these intervals to the left. Just make sure they're negative because we're going to the left of 0. So here is 0, right? Then we have -3 pi over 2 and -3 pi. Okay, so I'm going to do the original before the phase shift. We're starting lower, and then we can only move up, right? So at 3 pi over 2, we're at the midline. Remember each step. 3 pi, we're at upper. 9 pi over 2, we're at midline again. 6 pi at lower. So this would be our original graph if we didn't have the phase shift. Now, I like starting with 0 because we need our 0 going to the left 3 pi. Well, where is 3 pi to the left? It's right there. And as you can see, we move 1, 2, 3, 4 spots. So we're going to move each of these coordinates 4 spots. So here is the next point. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Happens to land right down there. 1, 2, 3, 4. And so this is our graph. Very good. All right, it looks like we're done, but we're actually not. So flip your paper over. Oh, mine's not on the back, but mine's on another sheet. Okay. These are story problems. We're not going to graph them, but we're actually going to create the equation. One thing I do want to point out is there will not be a phase shift when it comes here. So think of the things we need for our equation. First, we need to know what trig function we are using. We need to know the amplitude, the midline, and the period. So as we read our problem, we're going to see if we can picture this. We're going to see if we can get the numbers out. Another thing that might happen is you might want to draw it out. So the Ferris wheel at Lagoon has a diameter of 21.8. Diameter of 21.8. Well, a diameter, so if we draw our Ferris wheel, right, and it goes around and around, and let's say we have a little seat, right, little seats that go around. Of course, the middle of that Ferris wheel is going to be our center. The diameter stretches from that center. So what do you think that measurement helps us with? Well, if this is the middle, that must help us with the amplitude. So we have to take 21.8 divided by 2. We get 10.9. That means that from the center, we are 10.9 meters away. Okay? So that we can fill in as our amplitude. Okay, it rotates on the platform 3 meters above the ground. Okay, so of course this will not be 0, because I don't know about you, but if that cart is on the ground, you're not going to get up. It will scrape every time, right? So this Ferris wheel is above the ground by 3 meters. Well, what does 3 meters help us with? Well, doesn't that help us with the midline? So we have 10.5 here, and then we're another 3 meters. So our midline is 13.9. Our Ferris wheel completes 1 revolution in 40 seconds. That is our period. So our period is 40 seconds. Now, how does that help us? If you remember, the period is 2 pi divided by b. So we need to find b. Well, let's start doing the algebra. So we get 40b equals 2 pi. That means b equals pi over 40, which reduces to pi over 20. All right, so we have all of our pieces, but we need to look at what trig function we have here. So let's think of this situation. When you get on a Ferris wheel, where do you start? Well, we start down here, right? We're on the ground, right? And we're going to start by getting in that lower chair. So lower, well, midline is sine, so we're not starting at the midline, so it must be cosine. But then if we're starting lower, what does that mean? Hopefully you said that that means negative. So now we have all of our parts. So our function is f of x equals negative. Now we need our amplitude, which is 10.9, cosine, and then we have our b, which is pi over 20. Don't forget that's right out, well, we don't need that out front, right, because we're not doing a phase shift. So pi over 20. Here's what a lot of people forget. We are doing a function, so you need your x. And then our midline is a positive 13.9. And we just made our own trig function. Right, one more. So let me label everything we need. We need to figure out our trig function, our amplitude, midline, and period. The temperature throughout a day follows a sinusoidal. Now don't forget, that doesn't mean use a sine. It just means it's that wave curve. For the highest temperature of the day at noon is 80 degrees, and the lowest temperature is 60. Okay, what does that give us? Well, that means at noon, we are at 80 degrees as the high. And then if we go back all the way the next day to noon, we're back at 80. But our lowest point of the day is going to be 60. Okay. All right. Well, now we know that if we go from high to low, our middle is going to be at what? 70. So we have our midline at 70. What does that make our amp? Well, our amplitude would go from our high to our midline to our low, which in this case is 10. And we are talking about a day. So our period is 24 hours. So let's do that math, because that means that 2 pi over b equals 24. So 2 pi equals 24b. Solve for b. And that means we get 2 pi over 24, which is 1/12 pi. All right, so our b equals, and I'll put the pi on top, pi over 12. All right, now it says have your equation start at the highest temp. Well, midline is sine, so it has to be cosine. And then it is a positive cosine because we are at the highest. So let's put all of our stuff together. So for this one, we have f of x equals, our amplitude is 10 cosine. Our period is, or our b is pi over 12. Don't forget the x because this is of the function x. And then at the very end, add our midline. You guys are all set now to practice your phase shifts and creating trig functions from story problems.